Thanks, Anthony. Yes, I want to talk to you about what's called the Peatlands Climate Action Scheme, also known as the Enhanced Decommissioning, Rehabilitation and Restoration Scheme. We prefer the shorter Peatlands Climate Action Scheme. Basically the same scheme, and I want to talk to you about the initial water quality benefits that we're starting to see, and that we hope to see. How do we move down? Sorry. Oh yes, here we are next. Here we go. So a brief history of Bord na Móna, and we'll keep it brief. So we were formed in 1934 under what was called the Irish Turf Development Board, and then in 1946 Bord na Móna was established by the Irish government. Its original purpose was to develop Ireland's peatland resources, and that in more familiar times would have been the generation of electricity through a number of VSB power stations, horticultural peat for the growing media industry, and briquettes that people might have been familiar with up until 2 years ago when the last briquette factory in Ireland closed. The technology used at the time would have been mostly Russian technology in relation to milling peat, and then it moved on to Finnish technology, and we would have developed our own plant and equipment in those intervening years. And then we would have had a huge impact in Midland communities. There would have been a big employer between ourselves and the ESB, and that would have been a big part of the Midlands in relation to ongoing employment. So where are we now? So we ceased all production in 2019, and since then, and shortly after that, we started engaging with the department and the government on what's called an enhanced rehabilitation scheme. So we're licensed by the EPA, and back in '99, in their foresight, they installed a condition 10 in relation to decommissioning and the rehabilitation of all our peatlands. So I think it was determined as part of the scheme that we needed to enhance that, accelerate that scheme, and that's when we got the funding under the PCAS scheme for kind of speeding up that rehabilitation process on these number of peatlands between now and the end of next year. So it commenced in 21, and of December gone past, we have about 18,000 hectares of peatlands restored across a lot of the Midland counties of Ireland. So just to understand the extent of work involved, the history of peatland drainage excuse me, involved initial dewatering. So the bogs would have been drained back in the 40s and 50s. We then would have deepened that drainage after about 5 years to dewater the peat. We would then remove the vegetation. The drainage scheme would have been installed in every 15 metres to enable the production of peat. We would have deepened those drainage ditches every year as we removed peat for our various customers. Then as we lost our gravity drainage profile, we would have moved to pump drainage in a lot of the Shannon catchment bogs in particular. And then we would have ceased production, as said, in 2019, and since then we've been involved in the peatland scheme. So the scheme itself has a target of restoring 33,000 hectares between now and the end of the scheme. We targeted 82 bogs in particular. That list of bogs has changed over the years. We've been substituting bogs as other bogs have been unavailable. It's been supported by the EU's National Recovery and Resilience Plan of 108 million over the 5 years, and a Bord na Móna contribution of 18 million to try and get this work accelerated. The main driver at the time would have been under just transition, redeployment of ex-peat staff in restoring or repairing the damage, I suppose, that we would have caused to these peatlands. So it was great to be able to redeploy ourselves in undoing the drainage works and production we would have carried it over the years. It's managed by the department and is regulated by the National Parks and Wildlife Service. We have various stakeholders. Stakeholders we would build up relationships during our consultation process, so obviously all the local authorities. Some of these would have arisen from co-benefits that would never have been envisaged at the time of the scheme, so we would have engaged with various farming groups who would have had initial concerns about restoring peatlands. That would have been adjoining farmland and peatlands, etc. So we had to bring them on that journey. And then the various government departments and the OPW, National Museum in relation to archaeology, and various consultations with groups through our online forums at the time, because it was during COVID that we started the scheme. So the starting point is in the top right there. So this is what was ahead of us. We had bare production fields. They were all cambered to facilitate runoff of water. They were drained at 50-metre intervals. And all of our surface water discharge points were discharged through silt ponds. We were regulated by the EPA since '99, and we have 9 IPC licenses that would have regulated all of our 80,000 hectares of peatlands. So enhanced rehab measures going beyond the statutory obligation of condition 10 is the production fields were all blocked with peat drain blocks. We reprofiled the production fields to reduce that camber and slow the flow. Formation of cells then to try and hold water in areas where we had deeper peat. And we continued to migrate all of our surface water to our silt ponds, which are managed under our environmental management system. And then the important part for our neighbours was the boundary drains and the retention of their conveyings. So on the left here, an example of drain blocking. So a very simple process. Would have installed thousands of drain blocks to try and reduce water and contain it within these compartments. And on the right then would be more of the cell construction we would have carried out to bring water back up to high bare peat areas to try and reduce that interface of runoff. So the plans are developed through various baseline monitoring for water quality, hydrology, biodiversity and archaeology. We developed drainage management plans, hydrological assessments. We had to screen all of our plans, obviously. Archaeology, wetland archaeology, or peatlands in general are full of wetland archaeology, so we had to consider those in our plans. We then developed the plan, talked to our consultees and our stakeholders, submitted these to National Parks and Wildlife. We would have had various feedback and requests for further information. Once they approved them, we submitted them to the EPA. Once they're approved by the EPA, then we were able to commence work. And we have a programme of work every year, including this year, soon to start. So the fantastic database of monitoring we've been developed has allowed us to develop these dashboards, as we call them, for how we manage our hydrology and our carbon. Our surface water monitoring in particular for this event relates to the main two impacts on water from peat extraction will be suspended solids and in some contexts ammonia. And then we would have had a large network of piezometric tubes installed in a bog so we can verify that we are actually influencing the water table as opposed to just visual observations. So what factors determine what measure we apply? We started out with about 3 measures. It's developed into about 20 different measures now, depending on the depth of peat. The hydrology, any internal drainage networks, the volume or the nature of the bare peat. So some of peatlands we would have drained back in the day and we wouldn't have produced peat in them. So they are ideal candidates for restoration, whereas the peatlands that we did produce peat on, they're mostly a rehabilitation exercise. And then obviously pumped bogs versus gravity. The receiving water would have been an important factor. Our neighbours, obviously, and boundary drainage, and then archaeology. Archaeology would have had been, while it will benefit from the re-wetting preservation, we had to make sure we didn't damage it during our works. So on the left, you would have had a typical survey of our groundwater or surface water flows and indeed groundwater influences. And then on the right, we're looking to develop a plan with these suite of measures where we apply different measures to the deeper peat, to the marginal peat, ranging from the drain blocks to the cells you will have seen earlier on. So there's kind of 7 or so elements to peatland rehabilitation, and we do some of this work for National Parks and Wildlife as well. So an important part of any work is baseline monitoring. Sometimes you get schemes approved on a Friday and you have to have the money spent by a Monday. So there's never enough time there's never too much baseline monitoring, and we've been catching up a little bit on that. Then you develop your rehab design. Your land liaison and stakeholder engagement is very important to bring our neighbours on this journey in year 1 in particular and year 2, because our neighbours would have been familiar with us draining our peatlands and producing peat and would have worked for us as part-time farmers. So we then had to bring them on the journey of now we were undoing all of the damage we'd caused and that we weren't going to be impacting on their hydrology. So then we developed rehabilitation good practices and an environmental management system wrapped around that to make sure that while we were restoring our peatlands, we didn't cause damage elsewhere. Measurement of verification is very important. If you get 108 million under a scheme, you've got to show that it's money well spent. You've got to verify that what you planned, you expect to be the benefits, are arriving as benefits. The carbon elements would have been a very important element of this in relation to stopping the carbon leakage from bare peat that would have been drained, re-wetting that to re-oxidize, to retain the carbon, and then at some stage in the future, that peatland will have its carbon sequestration value. But it does take time, and every bog is different. And then the biodiversity monitoring enables us to identify the vegetation that's currently in place and what we expect to be there as part of our monitoring program. So that's just an example of some of the templates we've developed. That's the very simple method of draining blocks, block draining our intensive drainage system. They would have slowed the flow and arrested the drainage system. And the more extreme events then would have been, the more extreme package would have been the generation and the construction of cells to try and keep water perched up above this nice sweet spot of about plus or minus 4 to 5 inches, that the bog is wet during the winter, but it doesn't dry out totally during the summer. So there's kind of a little bit of a game there to make sure that you meet both of those criteria for rehabilitating the peatlands and providing the moisture levels for re-establishment of your peat farming communities. So on the left would be a typical bare peat bog. On the right then we see a picture of the production now rehabilitation teams constructing the cells. The bottom right then will be what we're left with following that, and then on the left-hand side is what we'll hope to achieve through one winter cycle, where all that water that would have previously been drained off the bog or pumped off the bog is now retained within these cells and drain blocks. So what are the benefits and co-benefits? We have to admit we didn't probably establish or realise all the co-benefits during the inception of the scheme. The main driver was under the Just Transition programme and redeployment of our staff, dealing with the statutory obligation of our licence to decommission and rehabilitate our peatlands, stop the carbon leakage, and try and enhance the biodiversity. So again, the enhanced rehabilitation was just kind of thrown as much as we could in a shorter period of time, as opposed to a basic level of rehab, which would have been drain blocks and wouldn't have given the results to Ireland Inc., I suppose, in relation to peatland restoration and meeting those targets. So the obvious co-benefit was water quality, and I'll talk about that in a second. Archaeology we talked about. Flood management, you're restoring the peatland's water retention capacity, which always would have been there prior to drainage. Amenity access, fire risk, illegal access, which we still have a bit of. Water abstraction pressure, so all of our pump drainage system would have been registered with the EPA under the water abstraction requirements. So now another benefit is that we're able to decommission and remove these pumps, so they're removing that pressure on groundwater where there is a groundwater influence. And then there are improvements yet to be measured, but I know in Scotland there have been some programmes in relation to restoration of upland peatlands that have shown improvements in organic loading at water treatment plants. So that's another core benefit that probably isn't been adequately measured. So the water quality issues from peatlands are well established. I think at this stage, the EPA's report in 24 identified ammonia and suspended solids as being the main issue. For us, suspended solids weren't really the issue in that we had a large silt control network that managed and monitored our silt ponds, but ammonia is an issue, and there was 3 actions developed in the Water Action Plan as it is now, and the first one was to work on our peat sector action plans with the National Parks and Wildlife, which we're in the middle of. Then we oversaw what's called a New Life Integrated Peatlands and Peoples project, which I'll talk about in a second, and then the scheme that I've just talked about, which is the Peatlands Restoration Scheme. The main issue from that said report was from peatland and peatland extraction as such is the release of pollutants to water such as ammonia and fine-grained suspended solids. And then obviously the physical alteration of the aquatic habitats. So to enable the peat extraction over the years, the OPW, the Barra Drainage Board, local authorities would have maintained drainage systems under various schemes, and they would have all benefited the peatland production activities and surrounding farmland. So you do have that residual damage to rivers in relation to modifications in hydromorphology. So our ammonia is produced when organic compounds are decomposed. So we're trying to re-wet the bog so we arrest that decomposition problem. So I think from initial discussions, there have been some improvements in water bodies generally showing a consistent reduction in ammonia concentrations. That's over the last decade. Can't really put our hands up and say we're responsible for that because we're restoring maybe one peatland in a catchment. We only own 6% of all the peatlands, so there could be other good improvements measures in a particular catchment that are also addressing that. But we are looking forward to see our water quality monitoring programme hopefully agreeing with some of the ones being conducted by the EPA and LawPro. So what we're trying to do when we block our internal drainage system in relation to surface water is to remove these gravity drainage pathways, to push water into higher bare peat areas, create these raised cells, as I call them, or water features to re-wet further. slow the flow of water movement across the bare peat that exacerbates suspended solids and ammonia and other nutrient mobilization. To retain winter flood water levels in lower peatlands, reduce the hydraulic gradients that would have been our reason d'etre for making sure the peatlands were kept dry for production over the years, to try and arrest all those hydraulic gradients, and then to return the peatlands water retention function, as I talked about earlier on. So some of the monitoring results, we had an obligation under license for quarterly monitoring, but that wouldn't have been adequate for the extensive monitoring program that would have needed to verify the improvements. So on the left-hand side here, I just pulled out 6 bogs or 8 bogs in various catchments. And what's important here maybe to identify, as we've added to our monitoring program from 2020 up to 2024, in green we've started to see a downward trajectory, an improving trend in our ammonia. So if you can see those circles in red, that shows that as we've been adding the year's monitoring data, we're starting to see ammonia trends from kind of flat in the early days of peatland restoration, and in some cases like the Clonard bog there, they were increasing, to a kind of a levelling out in end of 2023, and monitoring data up to December last year in these particular cases has shown that we're on a downward trajectory in relation to ammonia. The pH in relation to acidity of the peat is also heading in the right direction. COD is heading in the wrong direction, and it's kind of something we need to investigate further. It's obviously a naturally occurring chemicals and nutrients in peatlands that are exacerbating this problem, so we need to identify that this is an issue. And then the suspended solids are nearly down at the limits of detection, but obviously where you have slight rainfall events, while they don't exceed our license limit, you will have variations in suspended solids, but still you're down at a base level. So we recently got the EPA's water pressures data set. So we have a good GIS system, as a lot of state agencies have now, for managing our significant land bank, and we use that for tracking and ensuring that our monitoring program complements, if we can, the significant EPA's monitoring program, and hopefully to align our monitoring results and provide them to the EPA that they may correlate with improvements that they might identify at their monitoring stations. That's a big part of our management system on our geographical information system. So here's an example of Durham-Boy Bog. So Durham-Boy Bog is in the Silver River catchment, which would have been highlighted as a river that's under pressure from peat extraction and peat in general. So that bog was restored at the end of 23. So in the early years, we still had suspended solids heading in the wrong direction, even though they were still within our license limits. Ammonia was kind of flat, but as you can see, from adding on 12 months monitoring at the end of 23, we're already starting to see ammonia levels starting to head in that general direction. And you can see from bare peat cells, you're now in a situation where you have the area starting to green up as such, and your sphagnum moss is returning to try and help the bog to restore. We also do some work for National Parks and Wildlife and other third-party peat producers. This is an example of a peatland up in Mayo that we restored earlier this year. Again, that's helping to deal with water qualities and the issues in particular, but also just with the restoration capacity of that river or of that bog, because it was never in active production, so it already had a good head start in relation to vegetation. The Peatlands and People project, some bogs need a helping hand, so part of this project was the installation of sphagnum plugs. Sphagnum is one of the main building blocks of peat farming communities, so this is where we've installed up to 1 million peat plugs on some elements of our peatlands that needed that additional helping hand to try and accelerate that restoration potential. The next steps is to see if water quality trends continue. So it's okay saying in a particular year that water quality trends, positive in ammonia and everything else, head in the right direction. We have to make sure we continue that trend. We have an article published in the Catchments publications coming out. We have 14 bogs identified this year in Longford and Tipperary to restore. We need to see if this has been reflected in external monitoring programs, and then we're working with Emma and her team in the department on the peat sector plan with National Parks and Wildlife Service. We built up a big professional services team within the business, developing these plans so that and elements have been outsourced to third-party consultants enables us to generate this program of work. And then additional co-benefits finally on Project Connect, the fact that we're lifting a rail line. This is enabling a project where we're developing with Offaly County Council and Fáil Sharon access routes for our peatlands. The barrier removal project was where we would have installed crosses and bridges on our rivers, and some of those may qualify for funding under removal of these fish barriers. And then in relation to river restoration, we have a lot of bog timber, and as inland fisheries have identified, these might have potential to be reused in restoration and the creation of habitats for fish. So again, co-benefits that weren't originally envisaged. And there's some links to some further information. Thank you.